Welcome. Today we're going to take a little bit of a look at the data analytics lifecycle. We're going to explore how we transform raw data into some actionable insights and drive powerful results using Excel spreadsheets, publicly available data, and a publicly available web authoring data visualization tool called Tableau. Okay? So, a great deal of this course is administered via Coursera, and so we will center our lectures around the processes defined within the Google Data Analytics Certificate class. It's important to note that this is not the only way to operationalize or frame things. It is, however, a very good one, and if you intend to take that Google Professional Certificate, being familiar with it will help you on your journey as both a data analyst and as part of your wider analytic toolbox. So, a quick refresher. The 6 phases of data analysis process are to ask a good question, a business challenge that's objective to really understand what is happening. Prepare yourself by generating, collecting, storing, and beginning to manage some of that data. You're going to then process that data that you've collected, cleaning it, checking it for data integrity, completeness, things of this nature. Then you'll move on to your analysis phase, where you're going to do your data exploration, and then your visualization, and your analysis. And then we get to our stage of sharing, when we're going to be communicating our findings to one another and interpreting some of those results. And though we won't really act on it in the traditional sense of if we had a budget and we're a business, we will provide hypothetical solutions around our particular data analysis project about what could be done in a potential universe. So this week you'll be proposing your final topics. An aspect of completing the data analysis final project is articulating the data lifecycle for the data sets you will select when completing this week's assignment. So don't confuse the data lifecycle with the 6 phases of the data analysis process. Remember, the data lifecycle is an operationalized model of how we treat this data from ideation to deprecation. So first step is always to plan, decide what kind of data is needed, how it's going to be managed, and who will be responsible for it. Capture that information comes next, where you're collecting and beginning to bring in data from a variety of different sources. Then you have your management phase, where you need to care for and maintain this data. This also includes how it's stored, how it ends up actually being stored in practice, the tools you're going to use to analyze it with, as well as that data ETL part of things. You get your analysis phase, where you're going to use that data to ask some questions and begin that process of trying to understand what is occurring. You're also going to probably make some decisions too when we're thinking about the data analysis lifecycle. Once you've done your analysis, communicated your findings, and quote unquote acted, you're now at that stage where you're ready to determine what is going to happen with this data. Archival is very traditional. You'll keep relevant data stored for a long-term or future reference, maybe in a data lake, something like that. And then we have our destroy for data that has reached its useful life. Maybe a new policy has been changed. It's no longer, it's no longer illegal to collect certain information on people, or we have privacy preserving practices that are being implemented, things like that. There's various reasons why we may want to destroy data. And so that's our final step. And so in our data analysis project, one thing we will articulate is our own personal process of the data lifecycle and how we went through all of these stages while doing our final project. So we're going to start with problem definition and work to understand what the objective we are pursuing serves. Once we have defined things a bit in our planning phase, we can begin the process of creating and constructing our data. This data could come from many different sources. We're going to gather it, whether it may be internal data that we create, external data that's available freely on the web, or raw data that's been identified from sources. Once we've created our data and extracted it from a source system, we will begin the process of exploration. Now, this could include a running descriptive statistics to profile the shape of our data. We can also check for completeness and address inconsistencies and add additional features or relate that information to a different data set stored in another table or another place somewhere. That exploratory data analysis step is something we're going to undertake together on our final projects as well over the next few weeks in this course. And so it's an invaluable step in that analytic process. And it's here that we can also refine and test some of our hypotheses, identify new insights, and understand the shape and relationship of our variables and our features within the data. As we begin that process, we can also model and use some new AI tools or machine learning models that are out on the market and publicly available to play around with some of our data and see what other insights or information might be able to be pulled from it that might inform our analysis. As we move into the step of creating visual representations of our data, something we're actually going to demonstrate this week using, again, Tableau, there are many different programs that we can explore that will assist us in that data visualization process. And querying, programming language, all of that, there's different UIs and tools that incorporate different features. And so you're going to, as a data analyst and visualization expert in your journey, in your career, develop a preference for certain tools. Some folks like to script in R, others like Python and Pandas, some like SQL. So it really, that from a query language perspective, that might differ. When it comes to data visualization tools, folks like Tableau, others like Looker, there's, Domo, there's many different options out there. And then when we think about the GIS space as well. So never feel like you have to stick with one particular tool unless that's all that your employer licenses, and then, that's what you got to learn how to use in that scenario. But for your own learning, never worry about or limit yourself to just one tool. So today, dashboards and data exploration tools are everywhere. We're going to get into a lot of different ones over this course. Today, we're going to actually jump into the World Development Indicators that are developed by or published by the World Bank. But there's many that we will have the opportunity to explore in this course. And so just know that as you're searching for either open source or publicly available data, just to keep in mind the veracity and the reliability of the information and who's publishing it. In this class, we're going to set up a deployment to monitor insights from our data feeds of interest. Insights become actionable when data is used to monitor performance, track success of a campaign, or monitor the efficacy of a drug, for example. Often the data segments and sources that we utilize in an initial ad hoc analytic process can become key metrics for tracking performance and impact. In the industry, this is often referred to as KPIs or key performance indicators. A lot of ad hoc reporting does happen. There are often whole teams of analysts who are just ad hoc reporting dedicated. But often when we're undertaking significant analytic problems that have broad scope for a business, we're developing a process that's repeatable and hopefully can be automated so that much of the work then shifts to monitoring the data pipeline and not running a regular script or being asked to query and generate manual reports all the time. In a perfect world, implemented well, insights gained during a data analytic process have the potential to have many positive impacts on the quality of service provided to individuals, businesses, and entities. In other instances, the effective utilization of data can actually cause harm. And so we do need to think about the ethics and the value proposition behind the data that we are collecting, creating, and sharing in the world to ensure that what we are providing out there about individuals or corporations or countries, geographies, whatever it may be, doesn't expose anyone's sensitive information and improves quality of life in a significant way.